दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, we have discussed the preparation of the carbonyl compounds. We have taken the mnemonics for the preparation as H, O, D, head of the department, Royal Society. This is the mnemonics I have given you for preparation of carbonyl aldehydes and ketones. So this HOD is a general method of preparation of aldehydes and ketones. All the aldehydes and ketones can be prepared by HOD method, and this RS is the only specific for those of aldehydes, not for ketones. So here H is hydrolysis of alkyl gem dihalides, then hydration of alkyne, then O, oxidation of alcohols, then O, ozonolysis of alkene, then D, the dehydrogenation of alcohol, and D, dry distillation of calcium salts of carboxylases. So of the 6 preparatory methods of preparation, the 5 methods of preparation I have told you we have done in alkene, alkyne and alcohol. So whenever you are coming to a new topic, a new subject in organic chemistry, it is as good as we are revising what we have read in our earlier classes. Hence, whenever you are reading 30 to 40 pages in one topic, then out of 30 pages, only 10 or 12 pages will be new, rest 20 pages will be a revision of earlier classes if a student has followed the class properly. Now I have done last class hydrolysis of alkyl gem dihalide. When an alkyl gem dihalide is hydrolyzed by treating with sodium hydroxide and potassium hydroxide, it forms a dihydroxy compound. The dihydroxy compounds are unstable, they lose a molecule of water, they form the corresponding carbonyl compound. So depending upon the aldehyde or ketone we want to prepare, we will choose the alkyl halide. Suppose you want to prepare acetaldehyde, 2 carbon atom alkyl gem dihalide I have choose. So that is CH3, CHCl2, ethylidene chloride, when treated with aqueous potassium hydroxide or sodium hydroxide forms acetaldehyde. When you come to acetone, acetone can be prepared, so 2,2-dichloropropane when you take and hydrolyze we get acetone. Now we will come to then H. The second method is hydration of alkyne. What is hydration? The addition of a molecule of water. Hydrolysis is adding water, breaking a molecule. Hydration is a molecule of water will be added to the compound. The molecule will accept that molecule of water. So what is alkyne? Alkynes are the compounds that contain carbon atom bonded to another carbon atom by a sigma and 2 pi bonds. So what are the pi bonds? Pi bonds are weak bonds. Why weak bonds? They are formed due to the lateral overlapping up of the p orbital. The extent of overlapping is very less, and these pi electron clouds are loosely held electron clouds. They are more diffused into the space, hence act as a source of electron and undergo addition reaction. Now we will add water. Means how this molecule of water is added? In organic reactions, water is never added. Water comes from the reagent. So what is the reagent? we take mercuric chloride, mercuric sulfate plus sulfuric acid. So we take a mercuric sulfate plus sulfuric acid and we heat to about 75 degree centigrade. So what will happen here? They will subscribe a molecule of water. So this pi bond, one of the pi bond will break. So then what will happen? C, now C remains, this bond is open now, this pi bond remains. So one side H will be added, the other side OH will be added. So this is a unsaturated alcohol. We get an unsaturated alcohol. So this unsaturated alcohol undergoes rearrangement. So this hydrogen atom will come to this place and the double bond go to that place. So this will get a carbonyl compound and we get this. So this undergoes rearrangement. To form that C will get CH. This hydrogen will come to this place H and we get here H and here H and we go here O. The compound will get the CHO. So this is the way rearrangement we get the compound. So this is CH, suppose you have acetylene, so CH3, so these are the there. So this H will come to this place and O will be added here. So we get the compound here in rearrangement. We'll get the compound like this. C, H is there and H will come to this place. Then C, O, this compound we get. So this is a enol form. What is this? Enol form. Here is what? Double bond and OH. So this is a enol form. And what is this? A keto form. So this arrangement take place at atomerism. So but this compound is purely formed. Now see, suppose you want to prepare acetaldehyde. If you know this, then you can choose the compound. What compound we want to prepare acetaldehyde? Then what this should be? This should be H. And this should be H. Why? What is the formula of acetaldehyde? CH3, CHO. So if we write here H and H here, that means here H and here H, we get here CH3, CHO. So no question of remembering that I will take acetylene, on hydration produces acetaldehyde. If you know that a triple bond, carbon-carbon triple bond undergoes hydration reaction. Mercuric sulfate, sulfuric acid. So this is a compound. This undergoes hydration reaction. So one side H is added, the other side OH is added. This enol form. So this compound, this hydrogen atom come to this place and this happens. So this hydrogen atom comes to this place and double bond go to this place. So we get the molecule here. This. So now if you want to prepare acetaldehyde, you write here H and write H. So here H, acetylene on hydration produces acetaldehyde. If we want to prepare acetone, so this will remain. What is acetone? CH3, CO, CH3. So this side CH3, this side CH3 and this side H. If we write, then you can get acetone. So starting material, we will do, instead of remembering the compound undergoing addition hydration to produce this, know this trick, then you write the carbonyl compound and this. Now let's come to preparation, how acetaldehyde can be prepared. Now we will take acetylene. We want acetaldehyde. Acetaldehyde contains 2 carbon atoms. So we will take an alkene containing 2 carbon atoms. This is the alkene, this is acetylene. Now this undergoes addition of a molecule of water. There is mercuric sulfate and sulfuric acid. There is a catalyst. They supply a molecule of water heated to 75 degree centigrade. So this H will be added to one place, OH will be added, one pi bond will break. So you will get CH. So this becomes CS2, double bond, CH, OH. So this is called vinyl alcohol. Vinyl alcohol. Now this bond will come to this place, this and hydrogen will come to this place. So this hydrogen atom comes to this place and this goes to this place. This is the rearrangement take place. So this undergoes rearrangement. To produce CS3COH. This is acetaldehyde. This is acetaldehyde. When acetylene heated with mercuric sulfate and sulfuric acid undergoes hydration reaction to form vinyl alcohol, which undergoes rearrangement to produce acetaldehyde. What is this acid? They are what? They are functional isomers. Acetaldehyde and vinyl alcohol, they are functional isomers. Now we want to prepare acetone. Suppose you want to prepare acetone. If you want to prepare acetone, we will take CS3, C, triple bond CH. We will take this compound. An alkyne containing 3 carbon atoms we will take and carry out the hydration reaction. So this is mercuric sulfate and sulfuric acid, heat. So now this bond will break. So this go by the Marconi-Kov rule. During addition reaction, the hydrogen atom is always added to the carbon atom which contains more number of hydrogen atoms. So this contains more hydrogen and this contains less hydrogen. So this hydrogen atom will go to this place and OH will go to this place. This is a Marconi-Kov rule. During the addition reaction, the negative part of the addentum is added to the carbon atom which contains less number of hydrogen atom. So the OH group will go to this carbon atom, H will go to this. So we get this compound as CS3, CH, this will come CH, COH, this OH will go to this place. So this will come COH and a double bond CS2. There is allyl alcohol. Now this allyl alcohol will undergo rearrangement. This undergoes rearrangement. What will happen? This double bond will come to this place and the hydrogen atom will go to this carbon atom. So we'll get the compound as CS3, CO, CS3. This is acetone. So some student has asked me last class, sir, why acetone is called acetone? I told you last class that the aldehydes are named after the carboxylic acid. So it is an aldehyde of acetic acid, hence it is called acetaldehyde. So also the acetone is a ketone of acetic acid. If this acetone is oxidized, it forms acetic acid. If you take acetone, oxidize this will form acetic acid. You have done in second oxidation of alcohol. There you have done primary, second will take an isopropyl alcohol, oxidized, gives acetone, then acetone heated with constant sulfuric acid, potassium dichlorate, one of the alkyl group gets oxidized. This forms OH and this forms acetic acid. So it is a ketone of acetic acid. Children, wonderful question you have asked me in the comment box. If you remember this sentence, that the common name is a name given to an organic compound depending on its occurrence, origin, or the peculiar properties it exhibits, or a name given as such. So this is aldehyde of acetic acid, so acetaldehyde. And the acetylene, it is an unsaturated hydrocarbon of acetic acid, acetic acid. If you take acetylene, hydrolyze, hydration, you get acetaldehyde. Acetaldehyde and oxidation produces acetic acid. So this acetylene is a unsaturated hydrocarbon of acetic acid. Hence, with respect to acetic acid, the name is given to the hydrocarbon as acetylene, because the common name YLENE was used for unsaturation. Hence, it was named acet, YLENE, acetylene. So wonderful question you have asked me in the comment box. Thank you very much. Any questions you have, that will be definitely answered to you. And anywhere you are having doubts, if you put the question also, I will be explaining you again while teaching you the next topic. Now let's come. First is hydrolysis of alkyl gem halide, then hydration of alkyne, then we will come to oxidation of alcohol. Third method we have taken, the oxidation of alcohol. We have done this in alcohol chapter, that the primary alcohol on oxidation produces an aldehyde, and secondary alcohol on oxidation produces a ketone. So primary alcohol has two active hydrogen atoms. Suppose you want to prepare acetaldehyde, then our starting material will be what? A primary alcohol containing two carbon atoms. What is that? Ethyl alcohol. If you take ethyl alcohol, say CH3, CHOH, this is ethyl alcohol. Because we want to prepare acetaldehyde, so we choose, then this will undergo oxidation. What? Now this is dilute alkaline KMnO4 will do the oxidation reaction. Dilute alkaline KMnO4. Now what will happen? The H will be oxidized to OH. This is a clue. During oxidation, always the active hydrogen atom present gets oxidized to OH. So this H will become OH. So what will happen now? CH3, C, OH, OH and H. You got CH3, CH, OH, OH. Any carbon atom having two OH group is unstable. Any carbon atom having two OH group unstable loses a molecule of water. So this molecule of water is lost. So any carbon atom having two OH group is unstable, loses a molecule of water. So this will lose a molecule of water now to produce CH3, COH, acetaldehyde. Now children, then what is this? We will prepare. What is ethyl alcohol? It is a liquid whose boiling point is about 78 degrees centigrade. We have taken in a flask and you have added few drops of alkaline KMnO4. Then we reflux. We use a air condenser and warm it. Reaction will take place. So what will happen? This acetaldehyde has another active hydrogen atom. We have read in primary alcohol. Again this H will become OH. This will become OH. Hence, it is mentioned during the oxidation, the moment the aldehyde is formed, it has to be distilled out. During oxidation, the moment the aldehyde is formed is distilled out. It distilled out. If simultaneously you will have a system in our apparatus, so that we will remove this acetaldehyde. Then how this Somebody may question, now because the boiling point of acetaldehyde is about 21 degree centigrade and boiling point of ethyl alcohol is about 78 degrees centigrade. The boiling point of ethyl alcohol is about 78 degree centigrade and boiling point of acetaldehyde is about 21 degrees centigrade. Why? Now because here in alcohol they have intermolecular hydrogen bonding. Because of intermolecular hydrogen bonding, the alcohol molecules remain in an associated state, hence they have a high boiling point. And there is no hydrogen bonding in case of aldehydes and ketones. The only force of attraction among them is dipole-dipole force of attraction. So they have a lower boiling point, so it easily, very easily it can be distilled out. So during preparation of aldehyde, the moment aldehyde is produced, distilled out. So this is a question for 12th class students. In 1 mark question for in the board exam, the question comes, during preparation of aldehyde, the moment aldehyde is formed is distilled out. For 1 mark we will say primary alcohol on oxidation produces aldehyde. The aldehyde has an active hydrogen atom which is, so hence it easily undergoes oxidation to produce a carboxylic acid. To avoid this reaction, the further oxidation of aldehyde to carboxylic acid, this the aldehyde, the moment is formed, has to be distilled out. This is a 1 mark question. Generally it comes in the board exam. Now the oxidation of the secondary alcohol on oxidation produces ketone. Secondary alcohol on oxidation produces ketone. So secondary alcohol, suppose you take we want acetone, so we'll take isopropyl alcohol. We'll take an alcohol which contains 3, so this is isopropyl alcohol. Isopropyl alcohol. It contains 1 active hydrogen atom. Hence, when it is alkaline KMnO4, when you take alkaline KMnO4, it undergoes oxidation. So O is added here. The H will become OH. So this again forms a dihydroxy compound. The dihydroxy compounds are unstable because of 2 OH groups. Hence it loses a molecule of water. This loses a molecule of water to produce acetone, CH3CO. We get the acetone. So isopropyl alcohol on oxidation produces a dihydroxy compound and this produces acetone, the ketone. So same thing here, it will not undergo any further oxidation. Ketones, they contain alkyl groups, it will not be oxidized. Hence very easily we can say, we'll wait for the completion of the reaction. After the reaction is completed, we'll take out the acetone from this. So this is oxidation of alcohol. Now we'll come to the 4th method we have taken as the ozonolysis of alkene. These are the method for preparation of this ozonolysis. So if this is a compound word, lysis means breaking, means you will add ozone to a alkene, and after adding ozone to alkene, that will form a product, and that product will break. That entire process we will call ozonolysis. Now first let's say what is ozone. What is ozone? Ozone is a allotrope of oxygen. Is a triatomic oxygen. Ozone is a triatomic oxygen. Then what is the molecular formula? O3. Then how is its electronic structure? O, double bond O, and coordinate covalent bond O. So this is the 2, 2, and this is the electronic structure of this ozone. Means here is a double bond and this So oxygen, this is oxygen and O. So hence this is the coordinate covalent bond is a weak bond. Coordinate covalent bond is a weak bond. Hence this easily undergoes decomposition to produce O double bond O plus atomic oxygen. So what is this? This nascent oxygen. So ozone decomposes to produce oxygen and nascent oxygen. See, this nascent oxygen is oxidizing in nature. It can break a bond. It can break a bond. So this again, this breaks to form O, because this one bond is a sigma bond and one pi bond, so this bond, and we get this. So it means the ozone can produce a peroxide, is a peroxy linkage, and this is nascent oxygen, and both are oxidizing agent. This oxidizing agent, this oxidizing agent, and they break the bond. So the moment we add ozone to an alkene, the alkene has a sigma bond and pi bond. The sigma bond and pi bond both will break. So this nascent oxygen will break the pi bond, and this peroxy linkage, peroxide will break the sigma bond, and the molecule ozone will be added. It forms an ozonide. That ozonide undergoes on reduction. It forms a carbonyl compound. Hence, this is the thing. If you remember this theory, then it is very easy for you to write the molecule. Now you see, this is alkene, this is carbon, and this is a pi bond. This is a sigma bond, and this is a pi bond. What we are doing? We are adding ozone to this. Generally, this reaction is done in an inert solvent. So we will take either carbon tetrachloride, we take the carbon tetrachloride, the inert solvent, to carry out the reaction. So this bond, now what will happen? The pi bond will break and sigma bond will break. So what will happen now? So this is the C remains here and C remains here. The pi bond has broken and oxygen atom will be added. The pi bond broke and oxygen atom is added. Then sigma bond will break and oxygen atom will be added. So this forms this. So this is called ozonide. This is ozonide. And this ozonide is unstable because of the peroxy linkage. O single bond O, this is called peroxy linkage. Because of peroxy linkage, because of this peroxy linkage, and this ozonide is unstable. Means it has a tendency to undergo decomposition. Now, if we add hydrogen in presence of palladium, then that compound will break. That will break. How it will break? Now I can tell you, children, you remember always the break in a Y band. It will break in a Y band. If you remember this Y band, it will break in a Y band. You can write the product very easily. Y band means Y. Now you write Y here. So this will break, and this will break like this. Y band. I say you put the Y on the ozonide. Put the Y on the ozonide. So what will happen now? This bond breaks. This bond breaks. This Y. So what happened now? CO carbonyl group, CO carbonyl group, and what is this? O H2 water. So this hydrogen will take O, this will form water, and we get CO and CO. Two carbonyl groups we get. Mixture of carbonyl compounds. Now if we want to prepare acetaldehyde, then what you have to take it? What is this? CH3H. What is acetaldehyde? CH3HCO. So you write here CH3H. So you get two acetaldehyde molecules. And if you want to prepare acetone, CH3CO, simply write here CH3, you get two molecules of acetone. So you need not remember that this I will take ozonolysis acetaldehyde. No, not necessary. See, remember, when an alkene is treated with ozone in presence of carbon tetrachloride, a molecule of ozone is added in between the carbon atoms containing the double bond to form an ozonide. The ozonide is unstable due to the peroxy linkage. Hence on, hydrogenation produces a mixture of carbonyl compounds. So depending upon the carbonyl compound to be prepared, the alkene has to be chosen. Just I am writing here. Now if you want to prepare acetaldehyde, we will take what? Now we want to prepare acetaldehyde. So we will take CH3, H, C, double bond C, CH3, H. What is this? 2-butene, but 2-ene. Now we take this and treat this with ozonide, ozone, O3, in presence of carbon tetrachloride. It will undergo addition reaction. So this will give us CH3, H, C, O, C, CH3, H, O, O. The ozonide. This is the ozonide, and this ozonide is unstable, and on hydrogenation it will break in what? Y bend. It will break in Y bend. So this will break, this will break, this will break. So it forms two molecules of acetaldehyde, CH3, H, C, O plus CH3, H, C, O, acetaldehyde plus water. So you got acetaldehyde. Very easy. No question of remembering this. You know the theory and do it. Now you want to prepare acetone. Suppose you want to prepare acetone. This is our acetone we want to prepare. This we want to prepare means two bonds of the alkene we want to prepare. So this two should be what? This should be, if you take this CH3 and CH3 here, now ozone, if you take ozonolysis, so this will form CH3, CH3, C, O, C, CH3, CH3, O. It is unstable due to the peroxy linkage, ozonide. This upon hydrogenation, hydrogen, palladium, it will break in Y bend. It will break in the Y bend. This will produce two molecules of acetone, CH3, CH3, CO plus CH3, CH3, CO plus water. Acetone. This we got acetone, and this is 1, 2, 3, 4. So at 2 carbon atom methyl, 3 carbon atom methyl, so 2, 3 dimethyl butene. We take 2, 3 dimethyl, 1, 2, 3, 4, sorry, 2, 3 dimethyl butene. So if you take, you can this. So this is the word called hydration of alkene. So hydrolysis of, we got the ozonolysis of alkene. We have got the format. Now we'll come to the D. Next class I will be discussing to you dehydrogenation of alcohol.